So hello, ladies and gentlemen, and welcome to the Reimagining Motion Sessions by AVL. My name is Maggie Childs, and it's my great pleasure today to speak to you and these wonderful people here about a topic that's very close to my heart, e-mobility. E-mobility actually aims to meet such ambitious goals. We really want to be emission-free by 2050. And in order to do that, companies like AVL have been researching for years. But AVL, in fact, has been researching for 20 years already, which is much longer than the topic has been in the mainstream. So I'm really happy today to have here with me three experts from AVL. First of all, to my right here, Gerhard Meister. He's business field leader of electrification at AVL. Then Luigi Giordano, he's director of electrification application. And last but not least, Jürgen Rechberger, who is a business field manager for hydrogen and fuel cell. This is a very exciting group. I'm so happy to have you here. Now, just to orientate so that I understand correctly, you work in a different department than these two, correct? These are engineers,
that's right.
so to say.
Right. So the two colleagues, they help the customer to develop their new solution, the new mobility solution. And on my side, there are the tools to develop that, to support the development.
Fantastic. So we're hearing a lot about e-mobility as the trend of the future. Going into that landscape, however, it is quite diversified. It's not just batteries into cars and it's all over. So what areas does AVL really think that we're going further into, that it makes sense to do research and development in? Are there different timelines for the transformation that we'll see on the market?
Well, maybe I can start on that. So we definitely see a difference between the passenger car, the commercial vehicles, the off-road vehicles, and all the non-automotive application. And for passenger car, we see more the pure electric traction. And for commercial vehicles, Jürgen maybe can say something about that. There is definitely the chance for fuel cell, hydrogen.
Yeah, I fully agree on that. So the key for these applications is energy storage, right? We need to store a certain amount of energy in a vehicle, in an airplane, whatever. And with a battery, we can store a certain amount of energy. But beyond that, we can store much more energy in form of hydrogen. Therefore, hydrogen will play a role as heavier the vehicles are and as bigger they are and as longer the distances they go. For example, the first application for that most likely will be long-haul heavy-duty trucks. We will see hydrogen in airplanes for aviation. We will see hydrogen or hydrogen derivatives. We call it these e-fuels, which are made out of hydrogen in marine and lots of other applications. So heavy duty, there's a lot of potential for hydrogen. But on passenger car, fully agree with the colleagues, the mainstream at the moment here is battery electric, and that's the way to go.
It's interesting to see how these markets are developing, of course, and there are physical restrictions, of course, to each of these solutions. When it comes to this fuel cell battery choice, is there a trend that AVL kind of wants to follow, or is there? I've heard about AVL's multi-source strategy as well. Maybe you can tell me a little about that.
Yeah, there's different options how you can get to sustainable mobility. Of course, we have the battery electric route, as just discussed, which is just by nature very efficient. So if you can directly use the electric energy, the battery electric vehicle is the perfect solution. It's 4 to 5 times more efficient than something that's running on synthetic fuels, to give you an example. Since the real bottleneck is on the production of renewable electricity or electricity from renewable sources, but the more efficient you are downstream, the easier the transformation can take place. We also have to differentiate between different regions of the world. In some regions like Europe, where the infrastructure is quite well developed, but the electric vehicle again has a great future ahead of it. In other parts of the world, let's take a look at Latin America, for instance, it's difficult to imagine e-mobility there a solution based on biofuels, so in the end ethanol, maybe supported by hybridization, is a much more viable solution for implementation. And that's the reason AVL works with battery electric, works with hydrogen and fuel cells. For instance, synthetic fuels, we need to have all the options out there because there is no one-fits-all solution.
So there's a new energy mix than the one we've been talking about over the past decades, but it's still a mix, and that's a very important factor. If we're looking into not just how this technology works, so fuel cells and batteries and these options for various applications, but also how do we make these affordable? I mean, when we go into production in manufacturing, we want to have sustainable mobility, but of course it needs to make economic sense for the industry. How do you marry those two ideas?
The solution starts already during the development. Of course, the customers have to reduce the cost of their vehicles to make it more affordable, and this can be achieved with smaller batteries, but maybe with the capability to be charged faster. And this is where AVL, for example, really support our customers, or making the electrical motors running faster, which means that they are smaller in dimension, needs less material, and this is also a possibility to improve the cost efficiency in designing and realizing a vehicle.
So that's working together with the customers on these solutions. And is this a similar process than what Jürgen was talking about before, about certain vehicles or certain applications just lend themselves to battery or lend themselves to fuel cells? Is that a similar approach with customers, that you say your specific vehicle, this makes sense for that?
It's of course such that in general, so as we roll out electromobility, cost and affordability is one of the key challenges we need to overcome as we go to scale now. Scale on the one hand helps. On the other hand, like what we see right now in battery cost, it has a big impact on the whole supply chain upstream, on the raw materials and raw material processing. And to alleviate some of those pressures, we also need battery cells coming to market. Sodium-ion batteries, everybody's talking about them. And it means that certain applications like stationary batteries, maybe also batteries on marine applications, they will use this type of chemistry. And it alleviates some of the supply pressure on the lithium-ion batteries that we need in the transportation. And this is one good example how new technologies really also help to reduce cost. And in general, as we move from one generation of product to the next, cost is always in the focus. We can have the greatest solution on this planet if people can afford it. It's pointless. Yeah. Luigi named a few examples. Let me add maybe a battery that's really designed for recycling. So we have just implemented a great solution where the cooling system does not require thermal paste. This is kind of a glue where you attach the coolant or the cooling system to the cell to transfer the heat. And we've just implemented a solution where you can do away with those thermal pastes. And in the next step, when you try to do recycling, you can much more easily separate the different materials from each other. That means in recycling, you just use a lot less energy to get again to better great raw materials. And it's another very concrete example of how AVL works on these topics.
I think it's really inspirational, because not only is the whole idea of energy sustainability or e-mobility, it's about making things more sustainable, but this entire life cycle of the solution is also, of course, a topic. I think we've talked now about the infrastructure that exists already in Europe a little bit. AVL is part of creating that infrastructure, and broad electrification is the future, we've heard now from many sources. But what are AVL's plans? I mean, I don't know who wants to answer this, but for helping that broad electrification effort throughout the West, let's put it that way.
Maybe I can start on the electrical side, and then Jürgen can extend on the hydrogen one. On the electrical side, we are not delivering charging station. This is not the business of AVL. But we can help our customer to make this charging infrastructure compatible with the many electrical cars. Because you have always to remember that an electrical car communicates with the charging infrastructure when you charge the car. There is pieces of software speaking together, and that is where AVL has competence in supporting the development of the fastest experience which the customer can have, instead of running the risk to be blocked at the charging station because the car is not compatible.
Right. These are kind of growing pains of the industry, of course,
which we try to avoid.
Yes, it's not easy. As things innovate, people are very, of course, averse to change. But we've also heard about the increasing importance of hydrogen, and particularly for the applications you were mentioning earlier. And we will have actually another session on energy and sustainability, where we'll go into deeper kind of thoughts about what sustainability really means in the energy sector. But could you tell us a little more about hydrogen and its potential impact on the world of mobility and where that will happen?
Yeah, no, for sure. I mean, hydrogen actually will, at the end of the day, and that a lot of people do not understand that today, hydrogen will also enable better electric mobility, because in countries like Austria, Germany, we will not have enough electricity simply. So we have made estimates that due to this decarbonization of all the sectors, we are focused on mobility at AVL, But on mobility, it's only a small part of the future energy. We need much, much more renewable energy in the future for industry, for buildings, for all the applications. We need to get rid of fossil fuels in all sectors, right? Therefore, the electricity demand will increase significantly, and it get beyond a point where we cannot produce them locally anymore. Therefore, countries like Austria and Germany need to import energy. And that's going to happen through hydrogen or hydrogen derivatives. We call that products made out of hydrogen. And they will then put into power plants to produce electricity. And actually, this is the way how we can close the gap in electricity supply and charge all our battery electric vehicles.
I think I'm not the only one who was very unaware of that necessity of having hydrogen in order to facilitate the infrastructure. I'm sure I'm not alone there. But we talk a lot about also green hydrogen and the kind of availability, the infrastructure, but also just kind of what are the current challenges? Why are we not there yet? Perhaps, maybe, I'm not sure if Gerhard or Luigi, you both look like you want to answer.
Jürgen, right?
Oh, okay. Well, you go ahead.
I see it very clearly, and I fully understand the trend at the moment to battery electric, right? Because at the moment, if we look into our CO2, we need to be fast on climate change, right? We don't have 50 years. Therefore, we need to focus on technologies which we can scale till 2035. We want to, in 2035, only sell CO2 neutral vehicles, right? And if we really look into the facts, we can only scale battery electric fast enough. Therefore, it doesn't make sense now to focus on hydrogen mobility or on e-fuels because we cannot scale it fast enough. So we need to do battery electric, and then we need to put the technologies there where they fit best. For example, hydrogen into long-haul heavy duty, into aviation, into marine. But in each sector, let's go towards what Gerhard already said, the most efficient way, because that makes us the fastest.
Yeah, and we heard before also about the cyclical or circular kind of economy of each of these developments. Luigi, maybe you could tell us a little bit more about the testing process, just so we can understand how we find out how these things are working.
Yeah, we made a couple of examples before. On the testing, of course, we are supporting the customer with test benches which can test these high-speed motors. We can test the batteries in all climatic conditions, emulating what happens in the road. But basically, what we do is that we are virtualizing the environment around the components in a way that the customer can validate in a very early stage, much early before having the prototype vehicle, what are the conditions on which the component will be.
That's a huge cost saver.
It is not only a cost saver, right? But it is also a time saver, because Jürgen mentioned we are under time pressure, and you will see there will become on the market a lot of new electrical cars which are developed in much shorter time than the conventional cars in the past. And this virtualization also helps the customer to validate the software updates which are coming then during the life cycle of the car, and which was before in the past a huge effort, and which will come in the future much easier, much more frequently to the end customer.
So it's really just bringing the whole thing a little earlier so that they can anticipate what they will need.
You can say that the machine is testing the machine, so we are virtualizing the process, we are supporting the customer with software tools and helping the customer to make it faster.
Well, I mean, I'm still very interested in seeing how this is going to progress and how the industry is going to evolve. What would you like to leave us with if you could have one wish for the evolution of this technology going forward?
Maybe I start?
Yes.
As far as e-mobility is concerned, the key point is everybody who hasn't tried it yet should try it. Fantastic.
Yeah, acceleration is absolutely amazing.
This noiseless propulsion is amazing. Yeah, also
quiet cities, imagine.
And the thing really is, or the point really is, if we look at these technologies, they have been developed to a level of maturity. They are really ready for prime time. So that means the infrastructure today, for the amount of electric vehicles we have out on the road, is quite good. It's not perfect, but it's very good, and it's really ready for prime time. And as we go forward, we clearly see that the trend is going in the direction of better electric vehicles, at least for passenger cars in the developed countries. So I can only say jump onto this bandwagon, and join the party. It's a great experience. And it's also very affordable in the end. Purchase prices are higher, but maintenance is lower, energy cost in operation is lower. there is actually at this point no reason not to do it.
And it's just lots of fun. I really love EVs. Okay, sorry, Jürgen, what would your wish be for the future of e-mobility?
Actually, I fully agree with Gerhard. On the vehicle level, I think we are pretty close to really a very, very good solution. The vehicle itself, the technologies associated to it will not the bottleneck. My concern is more on the energy side behind it and on the infrastructure, right? We need to get much, much faster there. We need dramatically accelerate the build-up of local renewable production. We need to be fast. We need to build up renewables, wind and solar, much, much, much faster. Otherwise, we really don't solve the problem, because then we drive electric vehicles, but they're coming not from clean energy. Therefore, we really need to put focus on energy and, of course, on infrastructure, right? At some point in time, infrastructure will become a bottleneck, so we need to be much more aggressive on that.
Yeah, supply chains are everything. I think we all just learned that at the latest in 2020.
This really needs to work in sync. Yeah,
absolutely.
Yeah.
And Luigi, your wish for the future?
Gerhard and Jürgen already said everything. Maybe the only thing which they did not mention is the interconnection of the electrical networks between the countries. Of course, we will need energy carriers like hydrogen for long-term storage, but having a better interconnection between the countries will definitely help to smoothen what are the typical oscillation of the renewable energy, so that we can maybe take the sun of Spain when the wind in Germany is not blowing. Yeah. So
that's a wonderful image to end on. I'd like to thank you guys so much for coming today to talk to me and give us a little more insight into AVL's really amazing things they're driving in innovation in e-mobility, and also the exciting journey it's taking with its customers. I think this whole idea of co-creation is also a very important thing in such a fast-moving sector. And of course, also, thank you for watching, and we hope you join us again for the next Reimagining Motion sessions.